All right, let's look at constant time with logic minimization. In the following code, there is a branch dependent on secret A, B, and C. Okay, so let's look at the code. We have secret A, B, and C, and these secrets are being used as a condition for a branch. So here the function, the condition is A, X, or B. And then later on, there is another branch in an else path. And here is an if C and else. Okay, so that's the situation. And then in each of the paths, the value of X is changed to 10, 50, or 80. So part A, draw the truth table, including the min term for each row. The part B is to minimize the logic using Carnot map and express the final expression. Okay, let's start with part A. Here, again, between the algebraic method versus the logic, let's choose the logic because we are going to do logic minimization. All right, so we'll start with BA, BB. This will correspond to ABC, right? And BC. Divided into 4. Right, I guess one more. All right, so we have that, and then we will fill this in as false, 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 true, 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 false, false, true, true, false, false, true, true, false, true, false, true, false, true, false, true, and then we figure out what is the value of X after with each of the combination. Let's figure out the first branch. So if A, X, or B, then X becomes 10, right? A, X, or B. So A, X, or B is true if one of them is true, but not both of them, right? So false X or false is false, etc. False. False X or true is true. So here X will be 10. False X or true, 10. True X or true X or false is true. True X or false is true. Okay, and then the rest of them, true versus X or true is false, etc. Yes, so we have figured out the first path that correspond to this. Okay, now let's look at the else. Okay, so for all the other cases, it depends on the value of C. If C is true, then we execute X equals 50, else X will be 80. Okay, so let's look at value of C. If it's true, then X will be 50. And there's another one here. And then if C is false, so that corresponds to that. And the last one is if if C is false, then this will be 80. And those two cases corresponds to this. Okay. So the part one is draw the truth table. So this is the truth table, including the min term, right? So let's draw the min term. So for the min term, we just look at the false. So false means not BA. False, that's an N, not BB, and not BC. And then and so on. So this would be not BA, not BB, and BC. False, true, false. Not BA, BB, not BC. False, true, true. So it will be not BA, BB, BC. True, false, false. BA, not BB, not BC. True, false, true. BA, not BB, BC. True, 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 false. BA, BB, not BC. Finally, it's all true. So it's BA, BB, BC. Okay, so part A is done. Now let's look at part B, minimize the logic using Carnot map and express the final expression. So now we are doing logic minimization. So because there are three cases in three possible values of x, so we'll have to draw three diagrams. And there are three variables, so we're going to do it like this. So let's say this is BA, BB, BC. So I'm just drawing the template first. So the first will be for when x is assigned value of 10. Second, if when it's assigned a value of 50. Third one is for when x assigned a value of 80. So in this case, we look at the case for 50. False, true, false, right? So false, true, false. Hold on. False, true, false. False, true, false, this one. And then false, true, true. And then true, false, false. True, false, false. The last one, true, false, true. Okay. So there are 4 cells. So we're done. For x equal to 50 is false, false, true. False, false, true. And true, true, true. True, true, true. And for this one is for 80 is false, false, false. And true, true, false. True, true, false right here. All right. So now we finish drawing the Carnot map. Okay, so there's some glare there. Okay, so next, let's kind of like discover the terms. So we're gonna have to cover these 4 cells with as big rectangle as possible that is size of power of 2. So we have one here. We have another one here, and that will be all. Okay. Here, what is the term here? Well, it contains BA because when BA is 1. And then it contains BB because BB is always 0, not BB. It does not contain BC because BC, regardless of the value of BC, we have 2 cells like this. And okay, let's be consistent here with the n sign. Now for this one, it contains not BA because it's 0. It contains BB. It does not contain BC because BC is 0, 1, and 0. So, okay, so then. Now we have the next, this one, we have two rectangles like this. The first one will be not BA, not BB, and BC. Okay, so not BA from here, and then 0, 1 is not BB and BC. Finally, this part will be 1, 1, 1. So it's basically BA and BB and BC. Notice something that because the cell, the rectangles are cell, these terms correspond exactly to the truth table. Okay, not BA, not BB, BC. That corresponds exactly to this one. Not BA, not BB, BC. BA, BB, BC corresponds exactly to the last row in the truth table. So basically, they are the same thing when the cell sizes are 1. But when the cell sizes are larger, this is when they differ from here. Okay. Now the final one. These are the two rectangles. Here 0, 0, 0. So it's not BA, not BB, not BC. And the last one here will be 1, 1, 0. So it's BA, BB, not BC. All right. So we have derived all the terms, all the rectangles. Now the final expression. So here, all those if and else's and all the statement will be replaced by this. Here will be 10. So let's get from the first Carnot map. So 10 times the integer of these two things. So it's BA and B, not BB. Or, so or will separate the terms, not BA and BB. Yes. Okay, so we're done with that, with the first one. Plus, okay, and then this is next is for this for x equal to 50. Okay, so this will be not BA and not BB and not BC, or BA, BB, BC, plus the final one, which is for 80, the case of 80 int, not BA, not BB, not, hold on, I think I make a mistake somewhere here. This is just BC. So here is not BA, not BB, and not BC. Or, and then the last one, BA and BB and not BC. Okay, that is the end for this problem.